발표 영상은 학생 경진대회 영상의 일부를 재편집한 것이며 프로젝트의 인터뷰 영상만을 담았습니다. 소규모 건축공사에서 프로젝트 참여자 간 원활한 소통과 BIM 정보를 효율적으로 관리할 수 있는 개선된 프로세스 모델을 제안하고 프로세스별 개발한 프로그램을 소규모 현장에 적용하여 적합성 및 효율성 검토를 목적으로 프로젝트를 진행했습니다. Field Agent is the program that identifies the most efficient site in a group. Geometry data-based input automatically calculate the floor area ratio and building to land ratio of buildings, suitable for site through analysis algorithm, and visualize the results in a math format.
After the design process is finished, we have to get building permit. It complies with the building code. For example, in Korea, there is a 세움터, the building administration system, and they manage every permit by those code. But it is very difficult to produce lots of drawings with the same quality all the time. Create the layers, add to sheet, adding text, annotation, dimensions, and so on. And this task is repeated for every project inevitably. Same building code, another project, same task, another building, again, and again. So we thought how we can change this. In conclusion, we could solve this by BIM model and Dynamo Studio. This system was created to prevent waste of time and manpower. At first, we classified building codes into a standard information system and matched the attribute data in BIM model with the building code. Next, we decide which attribute data should be expressed in the drawing by law. Finally, when they export it to 2D-CAD, we link those data with the building code layer. Of course, all of this information and rules was set into Dynamo. Input data will be BIM model. Output data will be lots of drawings with standard information. We called this automation of drawing generation system to shift to DWG.
Normally, it takes more time and manpower. But with our shift to DWG, the situation has changed. As a result, all of this process can be done in a few minutes.
We always think about the effective communication during under construction. Everyone must be able to know about these issues that have occurred in real time. However, the existing process is carried out through the message, phone call, face-to-face meetings, and it is difficult for information to record and shared. We think it reduces the efficiency, so what we were thinking about is active use of a web platform.
Google is the web platform that is accessible to everyone. The most important thing depends on how we use it. We actively use the applications such as the spreadsheet, Google Docs, and Google Drives. Spreadsheets are shared with the project manager, and everyone can see it all with their smartphone. Most importantly, we link spreadsheet and model in real time. This real-time platform manages the attribute data in Revit project and communicate the issue in the job site. Sometimes, this spreadsheet creates the Revit family or modify the parameter by reflecting changes made in the site. Well, in short, we are doing BIM on the web.
Checking the real-time process is the most important task in the job site, and sometimes it is a horrible work for managers. So we decided to this work to the machine with the 3D scan. The drone moves along the set GPS path every morning and sends the JPG data to the web in the real time. And those data is entered to photogrammetry solution like recap, and that images data will be converted into the 3D mesh model. We thought the value of the model would vary depending on how we use it. Someone only tries to guess the process by looking at this mesh model, but we didn't stop there. Because we have a BIM model that is built during the process, it means we have the huge sets of information in our Revit project and web platform. All the families of Revit project include lots of attribute data called 4D data, such as process planning, actual planning, price, and estimate.
We have developed a program that extracts 4D data through geometry data. This assembles the BIM model and conducts the 3-dimensional shape comparison with the 3D scan model to classify intersection and non-intersection parts by analysis. Based on the 4D data of intersection geometry, table can be derived from analysis of frame and external process. Also, internal process that cannot be identified only by 3D scan are organized through color analysis. Finally, by organizing the table, all the information that can be obtained from the current process, schedule, progress rate, and established rate such as the BIM model is uploaded to the platform to help the project progress by sharing it among project participants.